Okay, so let's finish up this lesson first by talking about a few more identities. So first of all, tangent and cotangent. You know that tangent is sine over cosine. So cotangent is cosine over sine. So that's just another identity they wanted to give you. And then there's these Pythagorean identities. These are pretty important. They come up a lot. So it's just important to remember these. So sine squared plus cosine squared equals 1. Obviously, there's a reason why they're called Pythagorean identities. And then 1 plus tangent squared equals secant squared, and then 1 plus cotangent squared equals cosecant squared. So another thing I want you to think about, though, is it is possible that they could write these in a different way. So maybe this is written as 1 equals secant squared minus tangent squared. That is the same statement, right? Another way they could write it is maybe they just say tangent squared is secant squared minus 1, right? These are all the same statements. So same thing here. They could write this as 1 equals cosecant squared minus cotangent squared, and so on, right? Okay, so that becomes important in a minute. So first, in example 4, they say let theta be an acute angle again. So they were still talking about these acute angles. And they want me to express sine of theta in terms of cosine of theta. So if they ask me to do that, the first thing I'm going to look for is what identity do I have that has these two trig functions in them, but that's it, because I don't want anything else. They want it specifically in terms of cosine, which means I can only have cosine in that side, okay? So they want me to express sine in terms of cosine. So I'm going to use this one because it has sine and cosine in it, and that's it. So what I'm going to do is solve for sine, and then on the other side of the equation, I would have nothing but cosine and any other integers that I have. All right, so I'm going to start out with this. Sine squared of theta plus cosine squared of theta equals 1. So to get sine by itself, I'm going to subtract cosine squared. So 1 minus cosine squared of theta is what I have left there. That's an S. And then I'm going to, if this is sine squared, it looks like I'm done, but I'm actually not, because this is cosine squared. I need it to just be sine, not squared. So I'm going to have to square root both sides to do that. So one thing that you need to remember, though, if you square root something, remember there's that plus minus situation. Well, if we're talking about an acute angle, sine of an acute angle is always positive. So I'm only going to write the positive scenario here, which is 1 minus cosine squared, square root of that. All right, so there my sine is in terms of cosine, and I'm good to go. Okay, part B, they wanted me to express tangent in terms of sine. So now again, I'm looking for something that has tangent and sine in it, but that's it. I don't have anything here, don't have it here, don't have it here, don't have it here. I do have a tangent and a sine here, but I have a cosine. But the question is, could I represent cosine as terms of sine, right? In terms of sine. I could do that. So I could change my cosine to look like sine to help me out. So I'm going to use this idea right here to help me with that. So I'm going to start out with this, that tangent of theta is sine over cosine. Then I'm going to use this idea that cosine, if I took this exact equation right here and I solved for cosine instead, I would end up with this exact same answer, except cosine of theta equals the square root of 1 minus sine squared of theta. So then it would be in terms of it. So I'm going to write that down right here. So cosine of theta would be the square root of 1 minus sine squared of theta, right? So I'm going to plug that in right here so that that's in terms of that. So my tangent of theta equals my sine of theta over the square root of 1 minus sine squared of theta. So then I have nothing but sine over here, and tangent is completely alone. So there's my answer to that one. Okay. There's a couple of problems in your homework that I don't feel like had any examples that look like them. So I'm going to do a few problems around those problems. So like I'm doing number 51 and I'm pretty sure I assigned number 53. So make sure that you're looking at these 3 problems when you look towards the end of the assignment, okay? So 51 gives me this problem, and in the directions it says verify the identity by transforming the left side into the right-hand side. So they want me to make the left side of the equation look like the right side. So they want me to prove, basically, I'm just proving this identity. This is an identity, and they want me to prove it. All right, so I'm just going to start rewriting things that I know are equivalent. So I know that secant is the same thing as 1 over cosine. Okay, so I have a cosine here. I'm just going to leave that one alone for a second. And that's being multiplied by secant, which is 1 over cosine of theta. And I'm leaving this side alone. I'm never going to change that right side. When they tell me to verify it like that, I'm leaving the right side alone. I'm only changing the left side. Well, cosine is the same thing as cosine over 1. So cosine divided by cosine cancels out. So I end up with just 1 equals 1. So I just verified it. That's all I had to do. I also could have said that cosine is the same thing as 1 over secant, and then I could have canceled the secants out. Same thing would have happened. So just come up with a way to make that equivalent. Okay, this one I felt like was a little more tricky. So it's really tempting to distribute things like this. But when I distribute, I'm going to end up with cosine squared times secant squared minus cosine squared, and that is not going to help me at all. So what I want you to do is go back and look at those identities. So let me go back over here. So I'm looking at this piece right here, this secant squared minus 1. I remember seeing a secant over here in my Pythagorean identities, right? So I had a secant squared right here. Well, they said secant squared minus 1. Remember earlier I rewrote this and said that is the same statement. The secant squared minus 1 is really just tangent squared. So I used this identity right here, but I rearranged it, subtracted 1 from both sides, and said tangent squared is really secant squared minus 1. Okay, so that means that the secant squared minus 1, that's really tangent. So I'm going to see if that helps me. Cosine squared times tangent squared equals sine squared. Okay, so now I need to know, like, is that true, right? So I've used that identity. Now I need to figure out how to simplify this and see if it equals sine squared. So the only thing really, I know that this is 1 over secant, but I don't really care about that. I know that tangent is the same thing as sine over cosine. So let's see if that helps me. So when I'm talking about tangent squared, really that means sine squared over cosine squared. So you can just square the top and the bottom, and that's the same thing. So I have this statement, and then again, if I think of this as over 1, those cosine squareds cancel out. So I end up with sine squared of theta equals sine squared of theta. So I verified it. So when you're doing these, I would go back, especially to your Pythagorean identities, but also just your basic, your sine, your cosine, your tangent, all of those, and see if you can come up with anything that helps you make those look alike, okay? All right, number 77, last one. It says in the directions, it says find the exact values of the 6 trig functions of theta if theta is in standard position and P is on the terminal side. Okay, so the first thing I'm going to do is I'm going to graph this point, okay, so that I can kind of visually see what I'm talking about here. All right, so -2, -5, -2, 1, 2, 3, 4, 5. So -2, -5 is right here. So there's my point. So I have, that is on my terminal side, they said. So if I'm looking at my angles like we were talking about earlier, this is my initial side. This is what I was talking about in the last lesson. This is my initial side. And then when I do my angle, that is my terminal side. Okay, so I have like this angle happening. But what I know is I've got this triangle. I went -2 this way, so -2 that direction. And then I went down 5, so -5 that way. And then here's my kind of hypotenuse of my triangle, right? So I've created a triangle. And they want me to find all of the trig functions. So they want me to find sine of, I'm going to call it theta, and then cosine of theta, and then tangent of theta, and so on, right? So I'm just going to go ahead and write them all out. Cosecant, secant, and cotangent. Okay, so that's all I have to find. So remember earlier I did an example where I said if I know what these two sides are, I can find that third side just using the Pythagorean theorem. So that's what I'm going to do here. I already know that that's -2 and that's -5. So I'm going to say -2 squared plus -5 squared equals my hypotenuse squared, right? Don't forget that it's squared. You could also call this r because that really is the radius of your circle if you're talking about a circle, right? Okay, so this ends up 4, oh, my pencil, again. Okay, 4 plus 25 equals h squared. So 29 equals h squared. So the square root of 29 equals h. So this right here, this hypotenuse, is the square root of 29, which is kind of ugly, but that's okay. All right, so then I need to remind myself that we had those rules earlier where we said, you know what? The rule for any angle at all is that sine is y over r. Do you remember that? And then cosine is x over r. Tangent is y over x. And then these three are the reciprocals of these. So r over y instead of y over r over x, and x over y, right? So I can use that to help me out here because I know that this is my x value because I went over that far. This is my y value, and this is my r value. Okay, so I'm just going to plug those in. So y is -5. That's a negative. R is the square root of 29. I'm not liking the look of that because it's got a square root on the bottom. So I'm going to say really that's -5 square root of 29 over 29. Don't forget your negative out front. And there's my sine value. Cosine, that one would be my x, which is -2 over my r, square root of 29. So this is really the same thing as -2 square root 29 over 29. I think the one on your homework that you get like this one comes out with much prettier values than the square root of 29. So you don't really have to do most of this stuff, luckily. Okay, this one, my y is -5 over my x is -2. So really that's +5/2. All right, and then this one, just the reciprocal. So this one is the square root of 29 over -5. You could also write that with the negative out front, like that. Either way is fine with me, so you don't have to worry necessarily about the placement of that negative. This one, the reciprocal of that one would be the square root of 29 over -2, or negative square root of 29 all over 2, like that. And then my last one, the reciprocal of this would be -2 over -5, which is 2/5. Okay, so I think just setting it up and making sure you know, like, here's my x and my y value. I got to find that hypotenuse or the r value. Then you can just move on from there. It's pretty simple.